Hello again. This is a small video where I'm going to talk a bit about the hardware of the stringent wall plotter and a few different considerations and things I went through building this. I thought we were going to start with actually the first one I built, which is this one. It looks kind of similar to the current versions. Biggest difference is that these reels for the thread or wire is at the bottom of the plotter. And that was a really bad design consideration because it made the whole thing swing a lot more than when I moved the weight to be more up in the top like it's in this current one. Other notable things with this old version is that it does not have an SD card. Instead, it only had a small plot file in the memory of the Arduino, which made it a lot less fun to do. Also, the mounting of the pen is perpendicular to the wall instead of slanted like in the new one. This was a really bad idea because then the tip of the pen is offset from where the wires cross, which makes any swinging motion very visible. In trying to draw a straight line would instead be very, very curvy. But I mean, it worked, and it was enough to get me interested in actually continuing with the project, so that's at least a good thing. I think one of the reasons why I started doing this was, I mean, this was a long time ago, and it was quite recently after I had gotten myself a 3D printer, so I liked 3D printing stuff. So obviously everything turns into a 3D printing problem. So I printed these reels for wire and the chassis. The reels in the first version are a bit bigger than the respective ones in the new one. That was also not optimal because the torque of the stepper motors is not that much. So it made it really easy for them to miss steps and not be able to crawl up the wall properly. Also noteworthy are these zip ties that are connected, and there's kind of an attempt to keep the plotter stable when it's moving across the wall and not wobble too much. I think I've experimented with a gazillion of different ways of making that happen. More recently, I've just added some screws to offset the whole thing, and no, I wouldn't say that works fine either. There's probably a lot better solutions. But it was a good start, and so I sort of took this and scrapped it, and then went into sort of the next generation of it, which would have the stepper motors on top, and also have the pen go in at an angle, so the tip of the pen is very close to the center of rotation when it swings. This specific one has all the electronics on a shield that I built for the Arduino, which was it's very convenient, but it's super boring because there are no LEDs on this, and sort of miss from the drivers that come with the stepper motors has these LEDs which light up very pretty when it's plotting. So while from a technical standpoint this one is very nice, it's super boring to watch, so I would not encourage you to do it this way. Other differences with this, I don't know, it's kind of the same. The battery goes in the back. I just put some Velcro on both the battery and the plotter, so it's easy to do things with one hand now. I have some Velcro on there, so you can just put the battery and it will stay and sort of keep the center of gravity fairly good for some definition of good. Probably, I mean, for hardware consideration of doing any type of wall plotter, I think the one thing that you should think about is to actually have the pen be very close to where like your center of rotation is, and for goodness sake, make a center of rotation. Don't have strings going out from the edges of the plotter, because that will give you just a lot of swing. Just have the lines cross in the middle, and then you will have at least everything close to the middle would move very little, even if the plotter is swinging. Let's look at some other. I have tons of hardware here to speak about. Oh, look, a paperclip. This is one of the most essential pieces of hardware on the planet. It can be used for so many things. For hanging a plotter on a wall, it's super good, because you can thread it to a string or wire and then put it up on a nail, or you can just bend it in various ways and hang it on just small edges and things. Super convenient. I also made some custom parts for hanging wire. This is for mounting oops, sorry. This is for a ceiling in the office where I'm at, where you can mount it at some just under the roof. There's some aluminum things you can mount it on, and you will get really good mounts for any whiteboard in the entire office, which is super convenient. Also 3D printed, but I mean, this could have been made with paper clips or gaff tape. One more of those. My favorite mounting option is a suction cup. Yeah, I didn't find any with mounting. I usually super glued a piece of a zip tie to this, and then you could just hang the paper clip from the zip tie. It works really well when you get the gluing right. It's a bit difficult gluing it so it actually will work as a suction cup. If it becomes too stiff, then it won't really stick. But very convenient, works for all whiteboards. Well, this is a battery. Important thing with this is a lithium-ion chargeable 9-volt battery, which is really convenient because 9-volt batteries are fairly expensive, and you're going to run out of power fast, so you want to have a rechargeable one. Bought cheap from China. Remote controls. That's an interesting topic. Here we have some different remote controls. When I started thinking about the design, I didn't have IR and remote controls in mind. I was just doing something. So actually the first plotter I did, this one, I think, at least from the beginning, the software didn't have any calibration routines, but it instead relied on the plotter starting from a triangle, where you would have fastened it in 2 points, 1 meter apart, and then it would hang on 1 meter of string in it. So you had like a triangle of 1 meter, 1 meter, 1 meter. So you didn't need to have any specific calibration. But then that was kind of problematic, because you needed to fasten these at a specific location. But then quickly I figured out that, well, if I could do a calibration routine instead, then I could have these at any disparity and just do it. And then I started thinking about, what do I do about buttons? And I mean, if you have your Arduino and you want to have buttons, it's like it's quite a mess. I'm out of I/O pins, and then I figured out, hey, I can just put a regular IR. Well, there it is, the TSOP 4838. And I mean, that's a cheap component that costs a few cents, and then you could use any remote control. You just have to record the different keys and put it in your code, and voila, you have tons of buttons at no cost at all. Super duper convenient. Here's a SD card adapter, so because it's micro SD cards go into this and then into the laptop. Regular tape. This is very convenient. You can fasten the plotter to the wall with tape if you want. If you have a paper clip in the end of the string, you just put some tape over it. It's going to be good enough since the plotter is so light. Also, you can use tape to tape the wires closer to the wall. Because the closer to the wall they are, the better the plotter is going to hang. And well, here is a roll of sewing thread. Very convenient, very cheap. And here we have the fun project. So I have some written something about it and I have some pictures. This is the MacGyver version of the plotter. It works equally well. It's the same electronics, I just let it hang in the cables. So the entire thing is made out of this tie wire you use for like when you're doing concrete work and stuff, and these metallic straps with like duct strap things. And the reels are made of the lid from a milk carton, some cardboard from the same milk carton, and some with a hot glue gun. I just made it. And well, there's some wire in there as well. There's not even a single bolt or anything on this. It's just wire. And it works just as well as the others. I just made it to show to myself and you that you can make this without a 3D printer. You don't need any fancy tools or anything. It's just you can pretty much do it with whatever. Actually, this bending here was really good, adjustable for getting it to hang well with the wall. Much better than these flimsy things. So maybe if I build another one, I mean, this design is not that bad. Also, it's super easy to fasten the pen with just rubber bands to this, and I mean it's super adjustable. Everything bends in the direction you want, and I mean it's no special parts at all. Look, here is a rubber band. That's super useful. Looking at here we have here's a raw not used 3D print, so that's the chassis, and these are like the small reels, and there's a little hole in it. My video skills are limited, but you can see it's just hole so you can thread the wire around, this is super difficult and I have fat fingers, so that's hard. Much easier doing it like I did here. I just fastened a small bead or something there on the inside. So if you have a 3D printer at hand, I mean you can print one of these, and I mean it has screw holes for the Arduino and for the stepper motor drivers. Kind of convenient. 3D printing is always fun. So this is like the key component of the thing. It's one of these stepper motors. Dirt cheap geared down stepper motor with driver. You can buy them cheap by the piece, or you can buy them like in 10 packs or 25 packs from China. I'm not sure what they are used for initially, but they're really cheap. Also on the cheap side and convenient side, we have RC servo, one of these 9-gram thing. It's just standard with whatever comes in the package is like what's used to lift the pen away from the wall. I mean I usually clip away the connector and put something else to be able to connect directly to Arduino. I mean it's just get creative, use whatever tools. Hey, here's the brain, the Arduino Uno. So the plotter setup actually uses all of the digital input outputs, well, some of them are like this SPI interface, and also uses at least, I think this one uses one of the analog pins as well. It has a watchdog on the battery, not necessary. Arduino, very much fun. I thought I had this in the pile because this type of cables is so convenient. I always have ones with both male on one end, female on the other, or the ones with females on both. I mean, super useful if you have cables like this. I mean, you could do everything without soldering, which is nice. And here I have a long cable. I just made a cable with a battery connector on one end and a DC plug on the other, which I can use to power the plotter by cable from one of these. This is a huge lithium-ion battery for a headlamp. So with this, I can run the plotter for, I don't know, many hours on a battery, while on the 9-volt it's gonna run out much quicker. So I think that was pretty much all of the stuff I had on my desk right now, and this is not very coherent, this video, but maybe something is of interest. And well, if you do build something, I would encourage you to start off with something super minimalistic and simple, because it's not important how it looks and that that's like super fancy 3D printer, laser cut something. You just need something that you can connect to the stepper motors and roll in and out wire and put a servo somewhere, and then everything will just work. So enjoy and have fun building.